Just typing the title of this live, Finch3d. Good. Okay guys, you all know about this this meeting today. We're gonna meet a great architect, a Swedish architect, Jesper Wallgren. He's the co-founder of Finch3d. It's a plugin for Rhino. It will facilitate your work and it will do so much works you always suffer with. And we're gonna go live officially after 4 minutes. Jesper will join us after 4 minutes. I want to give you a small description about what you're gonna do today. Today will be with Jesper Wallgren, as I said, and will be a small introduction about him. He gonna tell us what he did after graduation, how he created Finch3d, what inspires him, and he will give us a small description about a small example on how to use Finch3d. Okay, as I said before also, Finch3d, it's a plugin for Rhino. It's like a generator. It's an automated system. You just put the numbers and the input, and it's like a magic. You're gonna see today, after a couple of minutes, how this Finch3d gonna work. So guys, how are you? How's quarantine with you? What are you doing? How you're spending your time? Let's talk a little bit about you. Waiting for Jesper to join us. I guess so. Jesper will join us. Now I will send. Okay, Jesper. Yeah, we are all bored. Hello. Hi, Jesper.
Hi guys.
How are you?
Can you hear me?
Yeah, it's a bit far away.
Maybe it's better without the headphones.
Oh, yeah, it's good. It's good.
It's okay?
Yeah, it's good.
Okay.
We're good. Okay. How are you?
I'm fine, thanks. Thanks.
Good. How's the weather?
How's the weather in Sweden? It's really great. You know, I've been out with my daughter at the playground all day, so I'm a little bit tan. You know, I'm a pale guy. It doesn't take much time.
You just turn red.
Yeah, exactly.
Yeah. Is it cold in Sweden?
Yeah, pretty cold actually. I think we have like 5 degrees or
okay.
Something like that. So
wow.
It's a bit colder than your place.
So, yeah, of course. It's like 40 degrees here in Saudi.
Yeah, that sounds nice. Much better.
Yeah. We're fried people.
Yeah.
we like fries.
Yeah.
So, how are you? What are you doing? How are you doing?
Yeah, it's Saturday night, and I'm doing an interview, so life's good.
Yeah, that's good. So, just 1 minute to reach 9 o'clock.
Yeah.
And so what you gonna give us today? I guess there's a lot of things you're gonna give us today.
Yeah. The idea is you told me you have a lot of architecture students and so on, so I'm going to tell you a story about what I did after my graduation, how I started my office, and that turned into Finch after a while. And as you know, I'm pretty into the whole parametric stuff or the parametric scene, so it's going to be pretty like Grasshopper parametric heavy in that sense. And then afterwards, I think I'm going to show you a couple of tools we're testing at some different international offices at the moment. And if you want to, I can also give you a little I can just build a quick Grasshopper definition here so we can have a look in, have some do's and don'ts and tips and tricks and so on.
Why not? So it's 9 o'clock, so we're officially on.
Nice.
So let's go. How's life after graduation? What did you do? How your career was?
Yeah, you know, you spend 5 years in school trying to prepare, and
you're an architect, right?
Yeah. I attended the architecture school in Copenhagen. Actually, it was a great school. I graduated from CETA. It's a computational department over there.
Nice.
But as I said, you spend 5 years trying to prepare, and all of a sudden you graduate and you're an architect, and you basically don't have any idea what to do.
That's it, yeah.
Yeah. So for me, it was I started to apply for a couple of jobs, but as I wrote the applications, I actually figured out I think I wanted to start my own office, and I figured, when you start your own business, it's always hard in the beginning. But I figured I was a student. I was used to not having any money, basically. So I figured that was the perfect time to start it. So I started my own office called Wallgren Architecture together with my wife. She's a furniture designer. And we started out super small. I mean, in the beginning, you just had to take what you can get.
Of course.
Some small extensions of houses, some and this kind of stuff, some redecoration and so on. But after a while, we got bigger assignments, basically.
That's good.
And it grew, and I guess we have done a couple of 100 houses with Wallgren Architecture, mostly like neighborhoods, larger dwelling developments and this kind of stuff. A little bit of commercial, but very pretty heavy at dwellings and residential, actually.
Yeah, I guess it's a fit out, right? Fit out works.
Fit out? What's that?
You worked as a fit out, the company for fit out. You just take the house and just renovating it, or just you build it from zero.
Yeah, from zero. Yeah.
Oh, wow.
I mean, in the beginning, it was pretty traditional architecture work at Wallgren Architecture. So we drew. I think the unique thing with us was that we drew everything in Rhino, basically.
Wow. So it's an opportunity, I guess.
Yeah, but I mean, it was a small office. We was 5, 6 when we was as most at the office. But what was pretty unique that we started out in Rhino, and pretty soon we started to develop our own definitions in Grasshopper. Okay. To help us draw more efficient, and that was the start of Finch. So I mean, we developed these kind of algorithms, one for dealing with groundworks, another one for dealing with the building volume and so on, and it kind of grew, and we started to post these tools, these definitions. We posted them at Instagram and LinkedIn, and it got quite some attention.
Yeah, I can see that.
And I think it was actually when a guy called Harry Ibbs at Gensler in London, he called me up and said, "Hey, what you're doing here? It sounds really interesting. Can you come over to London and just show us some of the definitions?" And that was the start of our collaboration. And then we figured out we're probably onto something here. So then we started another company called Finch. And what we're doing here is basically we're developing a design tool for architects, especially architects in the early stages.
Oh, that's good. So I guess Finch3d is officially live, or there's a subscription?
No,
there's
it will be. I think it will be released in the end of this year or something like that. At the moment, we're a small team of 5 developers that's writing the software. What we're doing right now is that as I said, we have a collaboration with Gensler, and we made a handful of other international offices. They're getting to try, or they're trying out some small tools. We do all of the prototypes in Grasshopper, Rhino.
Okay.
And they come with feedback and so on, and the tools that works really well, I bring back to our software engineers and developers, and we turn it into to code and a much more efficient way. Because Finch is going to be a standalone platform. It's not just a plug into Rhino, but it communicates well with Rhino.
How it will work if it's a standalone?
Yeah, the way we work now is that you're in your software, Rhino. We're going to start with Rhino. So you draw your volumes so you use Rhino as an editor, and then Finch is going to be a plugin where you send your information to our web app, where you do all of the settings and so on, very much like a Grasshopper, and then you get the result sent back to Rhino. So you're still in the Rhino environment, and what's important to stress is that it's going to be a super user-friendly tool for architects. You don't need to. You don't need to be able to write code or do Grasshopper or other parametric stuff. This is for the general designing architects that just want to create better buildings, basically.
That's cool. That's cool.
Yeah.
Best of luck.
Yeah, thank you. That was going well. So.
So it's a programming language, or just how to create this? How you created this?
Yeah, but basically. I'm not a software engineer. I'm
that's
a trained
what I'm
architect.
asking.
Yeah. As I said, I do prototypes in Grasshopper. How I want the tool to work, and when we have this, when we get it, when we show to other architects, they get to play around with it. We see what works, what not works. Then I'll take the prototype and I hand it over to the software engineers, basically. Or the developers, and they turn it into code.
Okay, so there's someone asking, so will Finch be a cloud-based?
Yeah.
Does it?
Yeah. It's going to be cloud-based.
How?
How?
Yep.
Yeah, it is a web app. It is a web app. So you sign in.
Okay.
So you have your own account. You sign in. You can save all your stuff, all your settings, and so on.
That's cool.
And wherever you are, or whatever computer you are, you can just keep on working on whatever you. So you get away from all this kind of hustle with files, and it's always the same at the end of a project. It's named Great Project Final Version 0.4. And then yeah. And if you're many people working at the same project, same files, it's even harder. So we're looking at the file. Very much, to be honest, very much like Google Sheets. You have a cloud-based thing that everyone can work on, like multi-user work.
Just a question.
Yeah.
What's the size of this software?
The size?
Yes. Is it heavy? Is it heavy on the PC, or is it heavy?
No.
Rhino?
Since it's cloud-based, it's very, very light per PC. You could basically have any old laptop to run it. And since it's cloud-based, we can actually use however much computer power you need. If you have a great laptop and you have like 4 or 8 cores, when it's in cloud, you can have 8,000 cores if you want to. So it's just much more powerful.
So how do you think Finch3d will change the way we design our buildings?
I think at the moment, when you attend architecture school, you dream of designing.
Of course.
You dream of doing great buildings. And that's great. That's what we all dream about. But then when you enter like the professional field, there is a lot of tasks that doesn't actually, just producing material for really repetitive stuff like putting doors and beds in and blocks and keeping track of everything. And the goal with Finch is to help the architect to automate this kind of repetitive task. So you spend more time on designing.
Yeah, go ahead. Sorry.
Yeah. And the second part of it is to help the designing architects make more informed decision. And what I mean when I'm saying that is that if we can provide the architect with live feedback, for example, I'm going to show you a couple of examples.
Just before, okay,
yeah.
we're gonna move to the examples part. Just we're gonna ask you some questions. There's a question here, but I have
sure.
one more question.
Yeah.
Does Finch3d support organic shapes or just linear?
No, organic, everything.
Oh, it supports everything.
Yeah.
That's good. There's a question here. How can we learn Finch3d? Is there any learning course or tutorials?
Not at the moment. When it will be released, we will release a lot of tutorials and learning course, but it's going to be pretty straightforward. It's a user-friendly interface, and it should not take more than a day to get into.
So the interface is so clear, so maybe you don't need a lot of tutorials. Maybe you have to understand the interface.
Yeah, that's the goal.
That's good. That's good. I'm pretty excited.
Yeah, yeah, we'll see. We'll see.
Yeah,
we're excited as well.
Of course, yeah, hope so. So let's move to the example part.
Yeah, sure. Maybe I see if I can switch the camera here to.
Yeah, no worries.
Just feel
so guys, we are moving now to the example part.
Yeah, I can do a couple of examples here. I mean, this is one. Sorry.
So guys, I'm sorry, but I'm gonna turn off the comments so you can see the full image. Okay, so here we go.
Okay, and just tell me if I have any questions or so on. I mean,
no problem.
This is one of many tools that we're working at. This is a site analysis tool, basically. Now I'm in Rhino here. As you can see, I've drawn a couple of buildings. I'm actually going to delete everything here just to take it from the top to see what happens here.
Okay.
Okay. I'm just going to turn everything on. Okay, here's the site. We're in Rhino. This is our lot. If I draw a volume here in the volume layer, let's make a tower here. Instantly, Finch generates slabs here, since I've said that each floor height should be 4 meters.
Can you just a bit zoom in, just to see the slabs?
Yeah, actually, I can turn them on like this.
Okay, that's good. Okay, yeah, that's good. Like good.
Okay, that's good. Pull it up a little bit. Okay, and you also get information here, how much space it used on the lot, how big is the footprint, how big is the floor area of all the combined floors, and how high is the building, and it's 14 stories high at the moment. Cool. And I mean, that's pretty straightforward. And of course, if I draw another building here, there you can see, then you get the information for each specific building on top of it like this.
Nice.
And I mean, I can keep on doing like this, and just a second, I'm gonna fiddle around with it a little bit like this. There you go. Now you can see these two are intersecting, and then I mean the total floor space is calculated as if it was one building, of course.
Okay.
Okay, but so that's the start, and then we have some auto-generated folks down here. But one thing I think is getting missed a lot of time, I mean, when you're designing, is that the topography that can be pretty tricky to deal with. So we also have some tools to deal with the ground here. For example, if I draw a line here, or let's make a little plateau here.
Okay.
Let's see what happens. Pull it up a little bit. There you go. They have a plateau around this building. As you can see, the ground just moved here.
Yeah.
And I can have some see like what's the inclination of the ground, how high is it, and so on. And of course, I mean, then I have my buildings here. I can turn on off the surroundings. You can choose whatever location in the world to just get the buildings auto-generated. And of course you get like the floor
sections.
plans.
Okay,
Floor plans, everything generated and so on. So this is more. I mean, it's been a popular tool. It's super simple per se, you know. But then again, it's about when you're starting a project, instead of sitting calculating all of these things, building surrounding. Generate the surrounding, spend a couple of days trying to get the groundworks right. All of this kind of thing is going to be generated automatically to save time, and then you can focus on generate. I mean, let's do fillet edge here. Let's do a little round edge. I mean, then I can focus my time on actually producing cool buildings in cool shapes. Let's do a cage edit here just to really mess it up a little bit. Let's see if it works. There you go.
Cool. Wow.
I mean, and now I've done some strange shapes here. I mean, it takes a lot of time calculating how big this kind of building is and so on. But now, I mean, we have it all. We know that this is 4,394 square meters, and this is really important when your client asks. I mean, if I just take a little break here, in the see if it works. No, I mean, in real life, when you work in a practice, you always have a specification from the client. I need to have a building that is this big, and this because I mean, we as architects, we want to create the best buildings, the most beautiful buildings in the world, but the clients always want a certain number of square meters, and they always want it to fit the budget. So that's life.
Of course.
Yeah. But I mean, that's just kind of the rules. We have another tool that also takes in consideration like the zoning laws and so on. So you keep within the zoning laws.
That's cool.
So I mean, you cannot design a building that's 200 meters high and then the city says, yeah, but we just want it to be 100 meters high. This won't work. I mean, then you have one angry client and
I guess
boss probably.
You had some people like this.
Yeah. I mean, No, but since I've been running my own office for a long, we meet a lot of clients and they work with other architects and so on. And I think it is it can be a tricky thing, you know, the communication between the architects and the clients, because I mean,
of course,
we all just want to create great architecture, but we talk different languages, and sometimes it can be really tricky to communicate. And that's what we hope that Finch can help you communicate better with your clients and so on. Because in our platform, in the web app, I don't have it up and running here now, but there is also like a presentation mode where you can present your ID, the building, and the client can get all the numbers they want, because that's what they want in the feasibility studies and so on.
Can we generate these numbers and this description of any plan or building as a PDF or as a Word file or something, or just to skip it on Rhino?
Yeah, I mean, from the web app, you can export it either to an Excel, PDF, or DBG, or those standards. And of course, we're looking at the BIM integration as well.
Yeah, it's the future, BIM.
Yeah,
that's why. Yeah. So we have another example.
Yeah, sure. I mean,
so there's someone asking, what's the most important thing to master? I guess I don't know what he means. Precisely
in the profession, or
I guess maybe you most important to think to master Rhino or Finch, or you have to have a real background on Rhino to run Finch, or just you run it and go ahead.
No, I mean at the moment we're using Rhino as an editor because I think Rhino it's a great tool. It's just nice to model different shapes and so on. I mean, you doesn't have to be a master either in Finch or Rhino in that sense. But I think I'm not sure if I get the question, to be honest.
No, no,
Or
I'm trying to fix it.
yeah.
Also, it doesn't exit.
Okay.
Oh, there's one commenting. How come Jesper is genius?
I know. I've spent too much
Okay,
time in the sun. I got sunburned.
let's see the comment section. How much? This is very exciting. Thanks for the hard work. Awaiting for this. And how much will be purchased? I guess he means the price. And do you recommend some master classes to generic design? Generic design.
Yeah.
Do you recommend any master classes?
Yeah, YouTube. To be honest, I mean, I learned Grasshopper and parametrics through a site called Digital Toolbox.
Digital Toolbox. Yeah. Digital Toolbox. Yeah.
Yeah, it was 10 years ago, and then I just Googled things, looked at YouTube tutorials, read up a little bit on math, I think, and then I just hung out at the Grasshopper forum, and people are super helpful. I mean, usually if you, I mean, you cannot, or maybe you could ask someone to do your definition, but if you have a question, people are super helpful.
The Grasshopper forum, you mean?
Yeah. Exactly.
Okay. Digital Toolbox, is it enough to learn everything about Rhino or Grasshopper?
Well, it was for me.
I guess there's a book by Arturo Tedeschi, the AAD. Yeah, I guess it's so helpful as well.
Yeah, probably. I mean, for me, and I'm just that kind of guy, I guess. I really like to just dig into YouTube tutorials and this kind of stuff, and especially the problem with or the great thing about things like Grasshopper, so it evolves so fast. So I think it's there's always new knowledge. There's always new knowledge. So and there's always a lot of people that doing new, great, cool things and so on.
So what is the method behind? Just what is the question? How easy is it to implement some structural engineering in Finch? Can you relate?
Yeah. We're talking to a lot of engineering firms actually. I mean, Finch is for architects. That's our main client.
Okay.
But what we're really interested in is providing the architect with information from the engineers. So I mean, if you draw a volume, it would be really nice to, and we started looking at and experiment a little bit with that. I mean, how if you choose a concrete structure versus a wood structure or a metal structure, how does that affect the building? I mean, does the walls turn thicker? Does the carbon footprint get up and down and so on? And then you can make more informed decisions when you get this kind of feedback on the structure as well.
Okay. There's another question. Let's see. Are you working on a facade script?
Yeah, we have a lot of facade scripts. Wow. I can show you a couple of. I can show you a couple of them here actually.
Of course. I'm so interested, to be honest, in facade design and this stuff and sustainability. So, what about sustainability? Does it calculate the energy? Does it it can relate or?
Yeah, that's one thing we're looking at as well. I mean, it's when it comes to energy and so on, there's just a lot of things to consider. Everything from transportation of material to the site and so on. If you really want to dig deep, but what we're going to look at first is more like geometry-wise. How does a window of certain size affect daylight energy, and how does a thicker wall? I mean, we're not going to dig that deep into it, so you can choose how materials get to the site, for example.
What's the limit of Finch? Does it work on big cities or just each building or a couple of buildings or?
Yeah, it's building scale, one or multiple buildings. It's not like a city planning tool. And another thing that I would say, it's from the first sketches to the building permit, I would say. So in the scale of 1 to 100. I mean,
Okay.
it's having that said, the idea with Finch is that it will help you out in the early phase of the project, as when you design like the main wide concept of the building. When you're going to make construction drawings and documentations and so on, the idea is that you change to BIM software like Revit, ArchiCAD,
Okay.
or whatever. Yeah.
That's cool. Will these plugins replace designers and architects in the future? We are afraid.
Yeah, no. That's not right. I mean, to be honest, I think all industry face the challenge of automation and AI and this kind of things. But I think, and of course, this is just my personal opinion. I think
Okay.
architecture is very subjective. There's nothing that's right or wrong, and I think it's kind of balance in between science and arts. And I think architecture, or the profession as an architect, is one of the professions that will actually deal with AI pretty well.
That's cool.
I think, and I must say, and that's a point as well. And I think it's important for our well-being, our cities, and so on, that still humans are trying to design better building. And then what tools we make to have to use it or to achieve this, that's, I mean, we'll see what tomorrow
Okay.
brings.
As you said, Finch3d is a standalone software.
Mm-hmm.
So your target is to work with Rhino only, or just to move to maybe 3D Max, maybe SketchUp? There's an integration
we have
with
all
these
doors
softwares.
open. I mean, we started in Rhino because I think, as I said, Rhino is a great tool, and I think it works really, really well. And we're starting out here. What the future holds, I don't know. For sure, we're looking at implementation in Revit and ArchiCAD, especially when it comes to extracting data from Finch, the results, and feed them into BIM software. That's going to be the first step. But 3D Studio Max or SketchUp or whatever, I don't know. That's very possible.
Yeah, it is.
Yeah.
So I'm gonna turn off the comments right now, and let's move to an example session.
Yeah, sure.
Okay. So guys, I'm gonna turn off the comments so you can see clearly. Okay, good.
This was actually just a second.
Yeah, take your time.
I think something happened to my headphones here. Can you still hear me?
Yeah, I can hear you, yes.
Okay. I'm just going to switch headphones. Sorry.
No, it's okay.
Okay. Can you hear me?
Yeah, yes, of course.
Yeah. I think my battery ran out. Okay.
You put the charger or something?
Yeah, it was for the headphone. No worries.
Good.
Okay. So this was actually a competition. Speaking of facade system, we made a competition at the architecture office, and it was based on a rigid grid system. It was 4.8 meters by 4.8 meters, everything, the whole grid system, as you can see here. So each cube here is 4.8 by 4.8.3 meters, I think. The reason why we had this was because we wanted to fit the parking lots beneath the building, and 4.8 was pretty good measurement in Sweden. Anyhow, so what we did was this kind of script that if you draw a footprint, you get a pixelated building generated. And then you get the information, how big it is, how high it is, and so on. And they can basically draw any kind of curve. Let's see. You want to generate the building like here. Wow. And you get something generated. And I mean, if you don't like the result, you can always change it a little bit.
Let's see. Based on what? There's an input? There's an input? Codes or something?
Yeah, in this case, we designed the algorithm that chops off the corners. and that was just like an aesthetic thing that we liked. So we have designed that algorithm.
Okay.
But what's interested here, let's say that, okay, we have a result here that we like. Then we go down here. Then we have designed, or the architects at our office designed a facade module. This is the kind of module we wanted to use for the project. And then we designed another module that's what's supposed to be used at the first floor or first story. And then we designed also like some terrace situations. And this, because this project was to be prefabricated. I mean, it was to be, all of these facade elements is going to be made in a factory and then shipped to site. And that's very popular these days. That's a very efficient way of building. But anyhow, then we wanted to implement this onto this volume. So then we wrote a script. Let's see. There you go. That bakes everything. And since it is blocks, as you can see, my module is like 1 megabyte big, so it's very light, and it's also nice. I mean, because if the designer or the architect wants to change something, let's go into the block here, and just move the window a little bit. Just move it out of the building, just to show an example. Of course, everything updates.
So it's a component.
Yeah, exactly. And if I hide it, so block, hide, you can see all of the slabs and so are all generated as well. And I mean, this is the kind of things that it doesn't. I mean, it's still someone designing the system, but it just saves you a lot of time that you don't have to fiddle around with everything this manually. When you, I mean, you could just if you don't like this one, let's delete it. Let's try something else. Let's delete that one, see what happens, and then you can just play around with it. I mean, and that's the idea, that it's going to be easy to use, simple, and so you can spend more time designing great buildings instead of building accurate 3D models.
So you design the building walls only, and then you design every part of it. Then you just apply it as like you apply a material.
Yeah, exactly.
That's it. Wow.
Yeah. And that one led to I'm going to show you a couple of other things here.
Just does the component should be the same size of the square or the grid you draw?
Yeah, in this example is, but let's see. I have another one here that we're working on. That was inspired by another one. So now we just have 3 components here, and I have, let's see, if we just remove that one from this building, I can just like this. Then I have a volume that I've drawn here in Rhino. To add a facade component to it, I basically just place it beside it like this. If I put it out there, I can just give my laptop a couple of seconds, and then you get it generated. And of course, it doesn't fit all the time. So now we're working on a smart scaling system that just scales all of the to the correct size. And once again, I mean, that's just because, I mean, if I wanted to, that's it. I want to make this building a little bit bigger, like that. I just have to think a little bit, and then
that's so much interesting.
And I mean, of course, if you have multiple, like here, of 2 different, I think I would like to put that down a little bit. I get it.
So in this case, when you want to design a facade with multiple designs, how it's applied? As we can see, there's a lot. The previous example, you just apply one component on the facade.
Yeah.
Based on what it generates, for example, 2 or 3 kinds of facades on the same building.
I mean, on this one, or I don't think I got the question.
Okay. The previous example you showed us, a building, a skyscraper with one component. You applied the component, or when you apply the facade design on the building, you apply from the examples on the side. You need the components you already made. It will combine them automatically or randomly, or what? Based on what?
No, in this example, it just takes the whatever component that I put close to the building and applies it.
Okay.
So I mean, if I would to delete that one, then
so it will be the same.
Yeah, then it's going to be the same.
Okay.
And once again, I mean, this is a prototype. This is what I've done in Grasshopper, and the purpose of that is that then I can take this one out to the officers, like for example, Gensler that we're talking to, show it to their architects and ask, does this make sense? And if it doesn't, fine, then we don't work anymore at that one. If it does, if they say, oh, this would help us a lot, then I take the tool to our software engineers, and then they make it into real code, so it's much faster.
I hope they will take it, because it's so much time saving, to be honest.
Yeah, this one seems pretty popular, so I think that will.
Wow, so interesting.
Okay, but maybe you have any? Do you have some questions here on that one, or?
Yeah, of course. Okay, there's a question. How can we customize Finch3d for surf purposes? Python or Java? You can see the question, right?
Yeah.
Oh, there's from someone called Finch Info.
Yeah, I don't know that one.
Okay.
but Finch Info. Someone trying to steal my identity.
I guess.
No, but we're looking. We had actually a really good discussion with the Danish office called 3XN, and one of their computational designers said it would be great to have like a node in Grasshopper, so all the results from Finch could be streamed out live to Grasshopper, because then them as digital or computational designers could use that information and build their own definitions on top of it. Most of Finch, since it's web-based, is going to be written in JavaScript, and we're looking at different APIs, how we can make the users. But it's going to be, I cannot stress that enough. It's going to be a low-threshold tool for designing architects, basically.
That's what I'm gonna say. It's not gonna be an open source application or website. So you can edit the programming language on it just for personal
we're looking at exactly on how we're going to do it. I mean, I love the open source culture. I love Rhino and so on, but at the same time, it's going to be a package as an online application, as a SaaS product, subscription-based product. So we're looking into how we can actually apply that, because we would love people to write their own stuff on top of it, of course. But at the same time, we will probably not be able to have everything open source, because that wouldn't make any sense for the business plan.
That makes sense. So, okay, there's a question. Can you show the comments for this, please? I don't know what.
I mean, maybe the nodes in the Grasshopper. And this is a really small definitions. I can just show you here. It's nothing. Just a second. Turn on the camera. This is how this one looks. It's based on a guy called Andrew Human. He has a plugin to Grasshopper called Human. It just grabs some elements in Rhino, and then we have a couple of operations here. I mean, wow. It's pretty small one here. It's straightforward. And I also used the where did it go? The Anemone plugin to loop the things.
Loop. Oh, okay, yes, loop.
I might.
Wow.
I mean, I can do a little example how just to speed up your definition and so on later. But I mean, this is a small definition actually. So they usually a couple of thousand.
So big. the biggest map I ever saw.
Oh, I made this in 1 hour.
Wow. So There's a question: can the software automatically design as per code, maybe building code or something?
We have a couple of tools that I say that a lot. We have a couple of tools. That's just because we have many different tools. No, but we have one tool that we're experimenting with, where you say, I want a building that's this high, that has this kind of footprint, this kind of roof slope, and so on, to fit the zoning laws. So yes, we have that.
Wow, interesting. There's one question: how is the increasing plan housing animation done?
Oh, the adaptive plan?
I guess the adaptive plan, yes.
That one got a lot of attention. It is, maybe I don't think I have an example.
Just a moment. My friend Ahmed, would it be compatible with organic and free-form design? I guess yes. I asked him this question. It's compatible, yes?
Yeah, some tools are, some tools are not. I mean, all of the facade tools and these kind of things are compatible with the organic shapes.
Okay.
And we're looking at it, but some of the tools, like the adaptive plan, is still pretty rigid to like squares and corner apartments and so on. I mean, it is. The whole thing with organic shapes is pretty interesting. Rhino handles that super well. I mean,
by the way, I don't like curves. I don't like organic shapes. I only like linear and straight lines. But my friends like the organic shape.
Yeah, but the linear shape will work for sure.
Yeah, of course. Let's see. Why you don't using organization colors in the group? Well, if you get the question, why you don't using organizing colors and the groups? Does it generate materials, or does it generate the building as a layers or something?
No, I think I mean in Grasshopper probably why I don't have grouped it. We use that a lot actually, and I can show you that in an example later. As I said, this was a pretty fast done prototype, so I mean I haven't organized that super well, but maybe I can just.
Yeah, of course.
I think most of the things I'm showing here is actually like work in progress. So, but usually we do it. It looks something like this. I'm going to show you that we group it pretty well. We organize it, and I think and I mean we name everything and so on. Okay. And I think that's super important, especially if you're. And I mean here we have like a huge block, and in this one there's a couple of 100 nodes as well. I mean it's if there's many people working on, and here is all the parameters that you can change basically. So if many people are working at the same script, it's super important to organize it well.
Yeah, of course.
Yeah.
Okay, so there's a question. Are you converting GH to Python or C code?
We're converting it to JavaScript.
Oh, JavaScript. Okay. And
since it's web-based, that made sense to us.
Oh yeah, of course. And Python, many code is from. How did you get this? How did you get this knowledge for generic design? Some advice for tutorials or books? I guess we.
Yeah, it's YouTube. But if you're interested, I mean, start following me on Instagram, because I post a lot of things. I mean,
of course, guys, you have to follow him.
Yeah.
Okay. Does it give sections too? Like not the section plans, the section, horizontal section.
Yeah. Not the prototype I showed here, but the tool that's the JavaScript that web app does section as well, and it does the facade drawings as well.
Okay. Every state has their own building design codes or bylaws. How do you solve that?
Yeah, that's a tricky one. the way we've gone about it at the moment is that you're able to change. I mean, the architects that design the building can say adjust the settings themselves to say that at this specific lot the building cannot be higher than this, and we're also looking at one tool where we're measuring distances from furniture to walls and so on. But our main, I wouldn't say that our main thing is like controlling things of building code in that matter, but for sure you can adjust it to your state or country and so on.
Okay. To apply different components at particular place in facade, like balcony, openings, are those position reference previously mentioned into script?
Yeah, I mean, if you want, basically, you can have like choose that I want balconies at one side and so on, but the idea is never to. What Finch is really good at and efficient at is creating this kind of starting conditions, and then the idea is always that you would tweak it yourself. I mean, Finch generate a starting condition, save it a lot of time, so on, and then as an architect you would probably say, hey, I want a special unit up here, and then you can always go in and tweak it afterwards by yourself, and that is the idea. It's never our idea to generate 100% of a building. We're very pleased we generate 50% and then keep the architect in the loop and make them design the last.
There's always we cannot lose the touch of the architect.
No, exactly.
It's always needed.
Yeah.
So how it doesn't matter how much we go for automation systems, and we still have the need to humans, to really human to design.
Yeah.
So
make no mistake. I mean, we have a couple of script. We actually were working on one definition for a really long time that generated 100% of a building, and it works here in. It was based on Swedish laws. So you basically draw a line and you get a full building generated with corridors, stairwells, and staircases, and floor plans and so on. But I mean, to me as an architect, it doesn't make any sense. I mean, then I would have designed all of the buildings in the world, and that's because, and so that's when we kind of pivoted and said, okay, let's just design. Let's make Finch generate like enough to save time and energy for the architect, like the repetitive, the boring stuff, the automate all these kind of boring things, and then the architect can spend the design actually designing.
Okay. So we got new question. Any education does it design? Okay, I don't know. Finch Info is so active with us. Does it design mechanicals or structures for building?
We're looking at structures. I mean, we're looking at load-bearing systems. As I said before, that you can choose whether you concrete or wood or whatever you want, but it's not like it's not a full engineer at the moment.
Yeah,
it's more like a guiding rule of thumb kind of thing.
Okay. Can I draw a house or just building big structure? It's for anything. It's for any building, right?
Yeah, mostly for bigger structures. Mostly for like I would say from
for skyscrapers.
I mean, you could draw a small house as well, but I mean, when you're designing a villa, there's not that many repetitive things in that sense. I mean, that's easier to design a villa manually. So I think you don't gain as much when you design a villa.
Okay, the big question: why the name Finch?
You know, it started out in Rhino as a plugin, and all of the plugins to Rhino has animal names basically. But the idea was that our building, or like it started out with an adaptive plan. It adapted to whatever shape, and it was just like Darwin's finches at Galapagos. Their beaks adapted to be able to eat the food wherever they, yeah.
Okay.
Like Darwin's finches was the inspiration.
That's cool. I like this question.
Yeah.
Okay. For generating plans, does Finch provide many options or just one solution? It's based on input, I guess, right?
Yeah.
Or something?
No, this is the $1,000,000 question here. No, we have designed a bunch of adaptive plans.
Okay.
It's not like the work of Stanislas. If you know Stanislas Chilau, he does this kind of machine learning plans. It's super interesting. But what we've done here is that we designed a plan with a set of rules. So we have actually designed the architecture. But what we're working on right now, and that we has got it to work, is a tool that takes your design and make it adaptive, basically.
Wow.
So you design a plan, or you're actually rather designing a family of plan, like if it's a two-sided apartment, for example, with exterior corridor, then you design like the one room should be like this, the two rooms should be like this, and how it grows. And then the tool combines that to one adaptive plan, so you get like the whole span, basically.
Oh, nice. Can we see an example of the adapted plan?
Yeah, sure.
Please. I guess
it is a little bit heavy to run here in Grasshopper.
Yeah, I guess the posting on Instagram started with the adapted plan, and it has a lot of views, to be honest. It goes so viral.
Yeah. Yeah, that was let's see, I don't think I have it here actually. Maybe I can see if I can show. Actually, I don't have the adaptive plan, but I have the tool of the adaptive plan. Just give me a second.
Okay, I guess I have the video. I guess you sent me the video.
Yeah, I can show you
this one.
Yeah, exactly. That
this
is
one. Oh, yeah, okay.
Yeah.
I guess it's the wrong one.
Yeah, if you have it there.
I don't know what is it.
That's me.
Yeah, that's you.
I can bring it here at my screen actually. Instagram.
Okay, good. Okay. I don't know where
the adaptive plan is this one. It is the adaptive plan. If you have not seen it before.
Okay, just let me turn the comments. Okay. So that's it. Yes. Is it heavier than generating the whole building?
No, or I mean, in a way.
Wow.
I mean, this is basically an animation of thousands of different plans. So each just generating one plan is very fast, but generating like an animation like this is pretty heavy.
Wow. Oh, okay. Do you generate it from Rhino, this, or just you record the screen?
Yeah, this is just from Rhino. But I can actually show you. Let's see. Just give me a second here. I'm going to show you.
No, take your time. Take your time.
I'm just going to fix some things. Just give me a second here. I'm just going to fix some secret things here.
Some secret things, yeah.
Some secret things I don't want to show live here. Just give me a second and I'll see.
Okay, no problem. Do you mind if I upload this session on YouTube?
Yeah, no worries. Upload it.
Okay, good. So there's a lot of guys asking me about this.
Yeah. Okay. That is, and that's still. Let's see.
Oh, okay.
So the original adaptive plan was basically just a definition that we wrote, and since then we've been looking at the tool, and we have this idea of maybe you could design your own adaptive plan. It's very early still, and it's just an idea, but we can see how people react to it. So basically, you have a plan that I've designed. This is just super simple. This is sketch. As you can see, here's no windows and so on. This is
2D.
just it's 2D. It's just a floor plan. Yeah, it works in a 3D as well, but this example is just in 2D.
Okay.
Okay, and then I have this kind of stretching line. How much can I stretch my apartment? So if I click max here, you can see that it stretches the apartment and it just moves the furniture so well. And the idea is that then I've designed like a couple of scenarios, like if it becomes a little bit bigger, it becomes like this, and if it's even bigger, it becomes like this. And when I deploy it to a, to a rectangle, it looks like this, and if I scroll, I can like change the plan size basically.
Wow.
And I mean that's pretty funky. And if I want to, let's see if it works here in this example, you can also apply it to a whole building basically, and if you change the size of the building, it just
it's automatically generated.
Yeah, but I mean everything that is generated here is based on my own designs. Basically.
Okay. That's good. Wow.
Yeah, so that's one idea what we investigated.
That's very cool.
Yeah.
So let's see if there's any question. I guess we are all good.
I have a question.
Yeah, of course. For me or for the audience?
Yeah, for the audience.
Okay.
Are you familiar with Grasshopper, or is it more like? I mean, if you're familiar with Grasshopper, just make a heart or a thumbs up or something.
So, guys, if any one of you work with Rhino, with the Grasshopper, or interested in Grasshopper, just make a thumb up in the comments. Let's see how many of you are interested or have an experience with the.
And you see a lot of thumbs and hearts.
It's all turn gold.
Yeah.
Where to start learning this from scratch? Any books or links recommended?
Follow me on Instagram and start cruising the Grasshopper forum. That's
fine. Go and support him, and he will work more for you. I'm pretty sure for this.
But if you want to, and if you have time, I don't know. I can show you just a little example of how I think with Grasshopper, and I mean it's going to be a little bit of a tutorial. Maybe take 5 minutes and so on. We just make a super fast facade thingy, and how I think and how you can optimize your definitions basically.
Yeah, no problem. Where we can do this.
Yeah, and then you can have, since we have some Grasshopper enthusiasts here, the second, let me turn it on. And you can just ask me questions along the way, if you want to.
Yeah, of course. So guys, if you have any questions, just try the question button, because I'm turning off the comments. I haven't finished one.
Okay. What I'm going to do here is just a super simple definition that creates a facade on this volume. So I've designed, this is basically a box. I mean, I made a box in Rhino.
Okay.
And this is usually how I work. It's going to be a small definition, just like 20 nodes. But I connect my box to Grasshopper. There you go, then I'm connected. And then I want to do some contours since I want stories. Let's go.
Okay.
Surface plane X, Y. just
Grasshopper is all based on logic, right?
yeah,
It's
exactly.
about the process.
Okay, so here we have the contours, and I can change the building.
Nice.
So let's put it to 3 meters. Oops, there you go. Now I would like to put some facade elements on this one. So I just take to explode my curves. This is my curves. I'm going to explode them. I'm going to measure the length of the curve like this. I'm going to divide it. I want my facade element to be 1 meter wide. There you go. I'm going to put some horizontal planes on it. Frames like this. Okay, there you go. Now we have some stories here, 1, 2, 3, 4 stories, and we have some planes where we want to generate some
All right.
facade stuff,
Okay.
basically. What I'm going to do then is basically, and I mean, if you're not familiar with Grasshopper, this might seem pretty far out, but for those who are familiar with Grasshopper, this makes a lot of sense. Since now I would like to have place a element here, and I would like to place it in the middle, in between there. So I'm actually going to do a little hack here. I'm going to put that one to 500 instead, and then I'm going to use a cull pattern. Just a second here. True. False. As I said, I don't know how skilled people are in Grasshopper, but I just want to show you how I think, basically. So,
Yeah, of course.
now we have where I wanted to generate a facade. So I'm going to generate a box here. And since, I mean, now we had one guy asking here about grouping. He doesn't, why I didn't group it much more. I always do it like this. And then I say, name it. I say, facade generator, blah, 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 or whatever. So, there you go. Okay, now I want to generate a facade element at this place. I'm just going to do box now. Box.
Okay.
I'm going to do a domain box. So here I'm going to put it. I'm going to make it 1 meter wide. I'm going to make it 300 millimeters deep, and I'm going to make it 3 meters high. Let's see what happens. Okay, so now we get some kind of boxes going here. I need to change this to a domain. Just a second. And it doesn't make any sense if you don't have used Grasshopper, but I'll get to it in a second here.
Okay.
I think for everyone that uses Grasshopper, it makes a lot of sense. Next part 2. Okay. So, now I have boxes generated here along my facade. And I'm very happy with that. Actually, I'm going to make this negative. And this is where people start getting it wrong, actually, when they're doing there. Now we have...
Baking?
No, I'm going to explain it here. We have too many sliders here. And
Yeah,
this is just, this is my personal opinion, how I model it. I have one slider here that says that the building, each floor, should be 3 meters high. And then I have the same number here that generates my box that also says it's 3 meters high. And what happens if I pull this slider, I get like a little thing in between the boxes, and I don't want that.
Oh, okay.
So that's not the way to go. The way you should have done it is that you use the same slider. So just remove this from this group and put it in here. Bam. So that way, when I use the same slider, the boxes updates as well. So that's like the super basic. This is pretty basic. This is like the basic And of course, we could do the same thing over here. We use that slider twice as well. Yes. X by 2. There we go. So now I can change the width of the everything as well. So always try to keep it as neat as possible. So you just have like as few sliders as possible. And then I would like to do some facade patterning. Just bear with me here a couple of minutes and it will all make sense. We can sell this definition later. Okay, now I would like to have a hole for a window in my boxes here. So I'm just going to scale my boxes like this. I'm going to scale it from this plane. This is a geometry. Let's make it 0.8 at that one and that one direction. Then I have a scale box here. Just a second. Now it starts to get really interesting. Now I want to do some kind of Boolean operation. And they are really heavy when it comes to Grasshopper. And this is where people get it wrong a lot of time. I'm going to go into the Boolean operation here. That's all the difference. I'm going to take this one. And now my computer will have to think a little bit probably. There we go. There we go.
Oh.
Then you have some facade elements. And as you can see here, you can see that this was pretty heavy. It's now we cannot see it because it's out of. Let's back it up a little.
Oh, it's strong. It's strong.
Yeah.
Okay.
It took me 3.3 seconds to calculate it, and that's really that's heavy for it. And I have a pretty decent computer here as well. So that's the problem here is that when you're dealing with buildings with a lot of repetitive elements like this, and you do a definition as I did it now, you get each element calculated. So each box is doing all of these boxes, I can see how many we have. We have 230 of them are doing this kind of repetitive Boolean operation. That's heavy, and that's where people really mess it up. What I should have done instead is instead of doing this one at each of these different places, I would do it like this. I would grab just an XY plane, put it into that one. What happens then? I do the same thing here for one. I have the box, I have the scaling, and I do it. All of a sudden, I'm just doing it with one element. It takes 13 milliseconds. It's basically nothing. I orient my new geometry into the planes from a building. Bam. You can see I get the same result, but I did it in like a couple of milliseconds. Wow. And I think when you and the biggest difference is now I can play around with it like this in Grasshopper in Rhino, and I can get this massive like big buildings calculated still on a laptop, and it's pretty fast. While if I did it like I did it before, it would like take 2 minutes to calculate it, and that would really just
So this is what
get you in a bad mood.
This is what the job of Finch.
Yeah, the job of Finch. Yeah, but I think if you're dealing with parametrics and architecture in general, this is just something that you should practice. Speed up.
Yeah, of course.
But maybe I'll do a couple tutorials some other times.
Of course, yeah, you have to. There's a lot of interest in it, I guess. Looking forward to testing. I'm looking forward to testing Finch myself. How long you finished one project? Yeah, it depends on the area, I guess, on the area. For the time of how much you need to finish the project. Did you have to build any of your own components for Grasshopper?
Yeah, it's a standalone product that connects to Rhino, so we're building everything from scratch.
Oh, okay.
I'm not building it. The developers at the company are doing it. I'm the product guy. I'm designing the algorithms and some other really smart guy is doing the code.
That's cool. That's cool. It was so interesting interview, to be honest. We had a lot of information.
Yeah, I'm happy to hear it.
Do you want to show us anything else, or there's something missing?
No, I think
Okay,
I think that's it. If there's interest, we can for sure make a tutorial.
Okay,
or
something. There's someone saying release it, dude. People are waiting for Finch. It's going to change a lot of things.
yeah. People say that. I'm really happy to hear that. But I think what we're doing now is just developing the product, because our goal is to basically release a really strong and good product, and
yeah,
I
of course,
it's important to have it all in place before, so we don't release anything.
So that's why it will take its time. It will take its time, I guess.
Yeah.
Another time, can we show how to double curves surface facade? Did you get the question?
Yeah, the double curve facades. Of course, it's. I mean, parametrics is super efficient when it comes to dealing with double curve facades, and we've done a couple of them. But I mean, I think when it comes to double curve, I mean, I'm not sure if Finch is the software to go, because I think when dealing with double curve facades, you usually have like a computational department at your office, because it's immensely expensive to build double curve facades. And I think when it comes to double curve facades, every project is super unique, and you always have to have a unique definition to deal with that condition.
My final question.
Yeah.
Where do you want to go? What is the goal of Finch? What are you planning to go, or what are you planning to do next?
I mean, the goal with Finch, it's pretty simple. We want architects to be able to design even better buildings that we already do. I think architects all around the world are doing a great job designing great buildings, and we want to help architects design it even better, even faster, even more efficient, and more informed, and so on. So that's the goal. Better architecture, basically. That's the goal with Finch. And what I'm going to do the next couple of years is my best to make it happen.
So that's cool. I'm looking forward to hear the best news of you and about Finch.
Yeah.
And it was a great interview.
Thank you. Thank you for having me.
There's someone asking, how do you think is Dynamo suitable for generative floor plan design?
I haven't used Dynamo that much, to be honest.
Okay, so I guess we come to an end.
Yeah.
Thank you so much for your time.
Thank you. Thank you.
And there's a lot of our friends, our audience are waiting for your great innovations in Finch3d. They want you to help them. Just to facilitate their work.
Yeah. And I can just say, visit www.finch3d.com and sign up at we have a mailing list. Sign up there, and we haven't used it much yet, but as soon as we start releasing things, you will get information.
Finch3d.com.
Yeah.
Good. That's cool.
Super.
Yeah, we will be waiting for this great plugin or standalone software.
Yeah.
And we're looking forward to hear great news about you. Stay safe, and you guys stay safe, stay home, and take a good care of yourself. We were Jad ElMourad and Jesper Wallgren, the great architect Jesper Wallgren.
Yeah, thank you.
Thank you so much. Thank you so much for your time. Bye-bye.
Bye.
Bye. Take care.